Welcome to the PetroPapers podcast. Say that 10 times fast. This is where you get your oil and gas intellectual stimulation by asking the technical questions. I'm Yogashri Pradhan, and with me here today, I have Mary Van Domelen from Well Data Labs and Adam Hoffman from Lewis Energy Group. Today, we're going to talk about SPE 201484, identifying casing failures with signature fracturing treatment pressure behavior. Been pretty passionate about this topic, and I'm really excited to have the experts today to talk about this. So welcome to the podcast.
Thanks for having us.
Well, I'm going to go ahead and get right to it. Either one of you can answer this question, but could you explain the genesis behind the topic and how this paper came to be and how it is moving forward?
Yeah, I'll kick it off and then you can follow up on that, Mary. For me at the time, I was working with Chesapeake. We had just acquired Brazos Valley acreage, started completing some Eagle Ford wells, and we discovered that we were tagging a lot of unforeseen deformations during the drill out. After we got a handful of wells in the ground, we discovered it was far more common than we were comfortable with. So that kind of initiated the research on our side. And then tying in with Mary, one of the programs we were using at the time was Well Data Labs, and we discovered it was a pretty powerful tool to kind of compare our data.
Yeah. So yeah, similar for me. I look at a lot of fracturing data through using the application from Well Data Labs, and I've also had my own experience of being on location with plugs stuck when I was running and drill out plugs caught at the same time. And it dawned on me that in the cases where we had problems with either running the plugs or drilling them out, we also had quote unquote abnormal behavior when we were fracturing the stages. And abnormal behavior can be anything from just an overall higher pressure to an overall lower pressure than what's expected, or from offset stages, or rapid increases in pressure, or near immediate drops in pressure. And so I started to realize that, there's something in this fracturing data that maybe we can't necessarily prevent the start of casing deformation, but we can be aware that it's happening. And as soon as we can be aware, then we can start the approach of going from a reactive to from a reactive mode to being proactive in trying to prevent problems during drill out.
I just want to compliment on how awesome the paper is and how informative it is, because when I first read the paper, I didn't have too much exposure on casing deformation, and this gave me a lot of education on casing deformation and the different types as well. So kudos.
Yeah, the paper's been out now for several years, and I've had several people comment. It's like it's got legs, it's still relevant, it's very interesting. I think it's exciting that people are still interested in it, this particular topic moving forward. And it kind of seemed like it was the beginning of people really discussing their issues.
Yeah. And there's been a lot of work. There's been a forum, there's a work group on casing deformation, and people have identified the different types of casing deformation, from tubular issues, which might have to do with poor quality control of the tubulars or inadequate design. Non-uniform loading would be another type, geological and geomechanic issues, and then operational impact. But fracturing of the well actually transcends all four of those types of failure mechanisms, because at the end of the day, it's most often the pressure and the cyclic pressure that comes from fracturing that causes that deformation.
That's really informative. I wanted to go ahead and ask, what are some of the pressure behaviors seen to know that a casing failure was happening?
Yeah, so my experience kind of looking at this data for multiple different basins, multiple different formations, there's kind of two tattletales. You kind of, the start is the the classic fluid loss characteristic where you're fracking right along and all of a sudden your pressure takes off and you have to drop your rate to control it. And then the second one are just these large instantaneous pressure drops, which was really kind of the focus on our paper after you had kind of seen this fluid loss characteristic, and then you would see 1,000 psi instantaneous drop occur, sometimes more than one, and that was kind of the thought process is, what's really causing it? Is it the pressure increase, or is it the pressure drop, or is it a combination of the two? And that's kind of where we were landed on it, is like it really might take both of them. But that's really kind of been one of the things you look at moving forward is, when these things occur, there's definitely something happening downhole that's not not what you would want to be occurring.
Yeah. Yeah, and I agree completely. I think Adam did a good job summarizing those two different behaviors. And one of the key to it is when you're looking at historic, and historic might mean at the end of the day, at the end of the week, or at the end of the well. I don't necessarily mean historic months later, but just looking at an average treating pressure, average rate, and an ISIP is not good enough. You need to be looking at what's happening and progressing through the treatment, because otherwise sometimes that increase in pressure happens quickly and not for very long. And certainly the drop in pressure is usually almost instantaneous. That gets washed away if you're just looking at the average numbers from the job.
Absolutely. If you're just doing a data dump of averages, you miss a lot of the finite details.
Okay. No, that's also one of the takeaways I got from the paper, in the sense that it takes multiple sources of data to really understand what's happening downhole. You can't just anchor to one source of data to just the treatment pressure or just the ISIP. So that was really informative, and again, that was a lot of education I got out of the paper. What would have been some preventative measures for casing deformation?
You want to go
I've,
first,
I've
Adam? Or-
Yeah, that's an interesting question. One of the things I like to think about is like, I don't think you're ever gonna fully prevent it, but I think you can do things to mitigate it.
Mhm.
I think it's George King makes the comment, when the earth moves, your casing loses. So obviously, when you're talking about when you're treating these stages and something abnormal is occurring with your pressures, obviously something abnormal is happening downhole. So I think it's just being very aware that what your normal treating pressures might be might not necessarily be what you should be expecting. So it's just, uh, it's being conscious of what's going on at all times. And having platforms kind of like Well Data Labs, or these other real-time platforms where you can be watching these frac jobs as they're occurring, actively communicating with the field and working with the guys out there. Just lines of communication, I think, is the most important thing.
Yeah. Yeah, I agree completely. I can also think about it in terms of a design, if you want to think about it in terms of risk management. Stress cycling, we know that stress cycling affects tubulars. And every time you pump a stage, the pressure comes up, it comes down. And so if you can design a well to be completed with, say, 30 stages rather than 60 stages, and design your clusters and your perforations such that you don't sacrifice performance, but you reduce the number of stages, there you go. You have less stress cycling, plus you have less plugs to be run. If you know that you're in an area with natural fractures that tend to slip, as Adam said, fluid loss can be important. Designing with a type of fluid that helps to minimize that fluid loss. Maybe it doesn't need to be a crosslink gel, but maybe going from slick water to a high vis water might help. High vis friction reducer. Proppant concentration can be important, because if you plug perforations, then you can get that immediate rise in pressure. Again, there's your stress cycling, which could certainly weaken the tubulars, but it could also cause a plug to slip, and then you could have erosions. So I think, being aware, identifying a problem, and Adam should talk to this because it was one of the things that they started doing, is look at your formation. If you think there's a stage where there might be an issue, there's a design consideration.
Yeah.
Look at your frac fluid and your frac design. There's a consideration. And then have contingencies for your field people so that they're enabled to make those decisions. And so, not to put it on you, Adam, but I'll leave it to you to talk about the approach that you use, because you were very successful by educating your field people in minimizing the problems that occurred.
Yeah, I think it all started with, making sure all disciplines were on the same team. You had your drilling team, completions team, subsurface team, geology, reservoir, just kind of getting everyone on the same page that, yeah, these things are what we're looking for. This is what, the drilling group, could you avoid these particular type of features? And, the geology group is like being better at identifying after the well's been drilled, the areas of concern. The completions group, tailoring designs around these areas highlighted before they happen. So there's a contingency plan when you get into it. And then working with the field group so they are aware that when something does occur, yes, you move into the contingency plan, but you're also making phone calls. It was just a really great experience seeing multiple groups just join in and say, yeah, we're going to make this happen, and then seeing it occur.
Yeah.
So there's a multidisciplinary effort that's involved. And
Yep.
there's definitely a balance of the frac design versus what you think the completion design is going to outcome in terms of the production that you're going to get. Because
Yeah, absolutely.
there's been
Yeah.
that perception that the more you pump sand and fluid into your formation, the better your well is going to be. Obviously, there's some diminishing returns into that,
Mhm.
especially with the casing deformation aspect of it. But there's a lot to take into consideration with the frac design.
Yeah.
Yeah,
Yeah.
absolutely.
I'd like to
Go ahead,
comment
Mary.
something on that. One of the recommendations might be that if you know it's a stage that's has a high potential for casing deformation, or if you see the signs of casing deformation, you cut the stage short. From a reservoir standpoint, often people will do an EUR per foot calculation and say, if we skip 3 stages, then we lose X percentage of our production. But I always like to think in unconventionals, we now know that you can drill a well and you can drain 660 away, 1320 away, even more. Why can't you drain, 200 feet from the next stage along the lateral? And so I think probably a study where people recognize that even if you skip a couple stages, you don't necessarily affect the overall EUR of the well, because you have drainage between stages, just like you have drainage between wells in a cube development. And I don't see people addressing that. That would have to come from the operating companies because they would have the data to back that. But my opinion is I'd rather skip a stage and not have to call out coil tubing or somebody or drill rig to mill out something.
Yeah. No,
Than
I'd
give up
say,
1 out of 40 stages.
yeah, I to echo on that, I think our industry kind of got to the point where it was you're drilling a horizontal well in a shale, the formation's the same over the entire lateral. Just copy, paste, and go, and then you crank up your efficiencies and try to hit X amount of stages per day. And then as the industry's evolved, we've kind of discovered, okay, that might not necessarily be the case. Maybe we do need to tailor our design in some particular areas, and it's just like I said, being involved with the group, knowing, okay, when the well is kind of steered in this bench, you have a higher chance of X, Y, and Z, or when it's steered in this bench, these designs react better. And, just being more of a tailored design based off of what you actually have instead of just one design across the board.
I smile a lot in this answer, this exchange. I'm a reservoir engineer, and I'm definitely one to do the EUR per foot.
Uh-oh.
Definitely one who's mentioned about the EUR per foot and the skipping stages, and there's plenty of debate in terms of how much percent of the lateral production are you losing because of that calculation.
Yeah.
I see a paper bubbling already in this conversation.
Yeah.
There's one more question I wanted to ask before I let y'all go, and I think it's an important question because I think this is one of the reasons why the paper, as you mentioned, Adam, that it still has so many legs after 4 years.
Yes.
What are the implications of this paper that the industry has never seen before?
So it's been really cool. We were talking before we even started, just kind of the evolution of this is, our paper came out in late 2020 and there was a paper kind of earlier that year, and those were really the first couple on the topic. And since then, there's been workshops. There's a dedicated work group that meets, every month with the associate with SPE. Just had a forum last month and I think there was 75 people and it was a global event. We had people coming in from Argentina and they were unaware that anyone outside of Argentina was experiencing casing issues. They thought they were an isolated incident, and it was just amazing to see dialogue bloom and people were seeing the exact same things in multiple different basins, and it's just being able to connect dots and just being a group sharing experiences and knowledge learning. It's exciting right now.
Wow.
Yeah.
Well, go ahead, Mary.
No, I was just going to say that was a really good summary, Adam. I don't think I can add anything to that.
Well, I want to thank you both for taking the time out of your day to be a part of this podcast and answering some salient questions and points about the paper. As I mentioned, the paper was a very great education for me as somebody who's a reservoir engineer who does the EUR per foot and is hard to date on understanding contributions to the lateral when in reality we're not really sure what's happening downhole for the most part. But I just want to commend you both on the paper and as well as the entire team that contributed to the paper and to the study.
Well, thank you very much. I love the feedback. By the time I finish writing a paper, I usually don't want to read it again. And I hope that it will be helpful to people. And it sure is nice to hear you say that.
No, this has been a great experience. Like, I just enjoyed working with Mary on this project, and when the paper got published and we presented on it, I couldn't have possibly imagined that here we are 4 years later and people are still interested in this topic.
Yeah.
Well, folks, the citation of the paper, as well as other references, will be in the description box below for our viewers and listeners on Apple Podcasts and the YouTube channel. This is Yoga Shri Pradhan, and we are signing off.